A line segment is a finite part of a straight line with two distinct endpoints. You can find the midpoint of a line segment by averaging the x and y coordinates of its endpoints. The coordinates of the midpoint of the line joining x1, y1 and x2, y2 are given by the formula x1 plus x2 over 2, y1 plus y2 over 2. So if we look at this first example, we're told that the line segment AB is the diameter of a circle, where A and B are the coordinates of 2 points on the circle. The coordinate of the centre of the circle is given by the midpoint of the diameter. So the midpoint joining -2, -3 and 4, 9 together. So the centre of our circle is equal to the midpoint of AB, which is equal to, and if we write down our formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. We can sub in what we know, so if we start off with this as our first coordinate, our first x value is -2 and our second x value is 4, so -2 plus 4 divided by 2. And again, if we look at our first coordinate, y1 is -3 and y2 is 9, so -3 plus 9 over 2. And we can work out each of these values. So -2 plus 4 gives us 2. -3 plus 9 gives us 6. So we get 6 over 2, and we can simplify that to give us the coordinate of the centre, which is 1, 3. In this second example, we're given the centre and B, but asked to find the coordinates A. If it helps, you can draw yourself a little sketch. So we've got a circle. We know that B lies on the circle. The centre is 3, 8. And the point B is -2, 6. So -2 is to the left of 3 and 6 is down, so -2, 6 is roughly in this area. AB is the diameter, so point A will lie over here, and we want to find the coordinates of that point A. So again, to do this, we're going to use our midpoint formula, as we know the midpoint of AB. So the midpoint M is equal to x1 plus x2 over 2, y1 plus y2 over 2. And again, we can fill in what we know. So we know that the midpoint is the centre of our circle, which is 3, 8. And that is equal to x1, so our first x coordinate, so -2, plus x2, which we'll just call x, divided by 2, and y1, which we know is 6, plus our second y coordinate, which we'll just call y, divided by 2. So now we can compare each term. So if we look at our x term from our coordinate, we know that 3 must equal -2 plus x divided by 2. And we can rearrange this to get x. So if we times both sides by 2, we get 6 is equal to -2 plus x, and x is equal to 8. And then we can do the same. So if we compare the y coordinates, so 8 must be the same as 6 plus y over 2. So 8 is equal to 6 plus y over 2. And again, we can get y by itself. So times by 2, on both sides, and we get 16 is equal to 6 plus y. Subtract 6 from both sides, and we get y is equal to 10. So the coordinate of A is 8, 10. So we're now going to look at the equation of a circle. For any point x, y on the circumference of a circle, you can use Pythagoras to show the relationship between x, y and the radius. The equation of a circle with centre 0, 0 and radius r is given by x squared plus y squared equals r squared. If we have a circle with centre AB and radius r, our equation is given as x take away a all squared plus y take away b all squared is equal to r squared. This is a translation of the circle x squared plus y squared equals r squared by the vector AB. To show that a point lies on a circle, substitute in the point and show that it satisfies the equation. You can multiply out the brackets in the equation of the circle to find it in alternative form. So if we follow the working below, instead of writing it in the form that we've just looked at, if we expand this, we can write the equation in the form x squared plus y squared plus cx plus dy plus a constant k. If we're given the equation in the form shown at the end, we can find the centre of the radius, but we must complete the square first for both the x term and the y term. So if we look at this first question, we're told the radius and the centre of the circle, so we can write down the equation of the circle. So x minus a squared plus y minus b squared is equal to r squared, where a is minus 4, b is 9, and radius r is root 8. So if we substitute these in, we get x minus minus 4 gives us plus 4, so x plus 4 squared plus y take away b, so y minus 9 squared is equal to root 8 squared, which just gives us 8. And then we need to expand this to get it in the form required. So remember that x plus 4 squared is x plus 4 times x plus 4. And if it helps, write it out like that. Y minus 9 squared is y minus 9 times y minus 9. And then we can expand each of those brackets. So we get x squared plus 8x plus 16 plus y squared minus 18y plus 81 is equal to 8. The form that we're given in the question is equal to 0, so we need to make sure we move every term to one side of the equation and collect our constant terms together, which gives us x squared plus y squared plus 8x minus 18y plus 89 is equal to 0. In the second question, we're given the equation of a circle but told to find the centre and the radius. So the first thing we need to do is complete the square for both x and y. So looking at the x terms, if we complete the square, we get x minus 2, so half of 4, squared take away our minus 2 squared. And then if we complete the square for the y terms, we get y plus 3, so half the 6, take away that 3 squared, and then we're left with the 8 at the end. So plus 8 is equal to 0. And if we simplify this, we get x take away 2 squared minus 4 plus y plus 3 squared minus 9 plus 8 is equal to 0. And we can collect the constants together, which gives us x minus 2 squared plus y plus 3 squared minus 5 is equal to 0. And we need the 5 on the other side, so it's in the form of the equation of a circle. So x minus 2 squared plus y plus 3 squared is equal to 5. Now write down the centre. So the centre of the circle is equal to 2. So x minus a, so a is 2, or the opposite sign of the number in the bracket. And y minus b, so b must be minus 3. Again, the opposite sign of the bracket. And the radius is equal to the square root of 5. For part B, to show that the point lies on the circle, we need to substitute in the point and show that it's true. So if we substitute in minus 1, 1 into the equation of our circle, we get 1 minus 2 squared for our first bracket, plus minus 1 plus 3 squared for our second bracket. And if we work out what that's equal to, so 1 take away 2 is minus 1 squared. Minus 1 plus 3 gives us 2 squared. And if we square each of those, minus 1 squared is 1, and 2 squared is 4, which gives us 5, which is true. Our equation of a circle was equal to 5, so the point lies on the circle. So we're given information in this question about the circle. So if it helps, we can draw a picture. And PQ, which is the diameter of the circle. So PQ and our centre in the middle. Where P is minus 10, 11. And Q is minus 2, 15. And we're asked to find the equation of the circle. So to find the equation of the circle, we need the centre and the radius. So we'll start by finding the midpoint of the two lines, which is the centre. So the midpoint which is equal to the centre is equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. So if we add our two x's together, we've got minus 10 plus minus 2 divided by 2. And if we add our y's together, we've got 11 plus 15 divided by 2. Which we can simplify to minus 12 over 2, 26 over 2. And we can simplify this further to get minus 6, 13. As the coordinate of our centre. We now need to know the radius, so we can work out the length between 2 points. Now we could work out the length of the diameter and half it, or we could work out the length of PC or CQ. We'll work out the length of the diameter using the points we're given in the question in case we've made a mistake with the midpoint. So the length of the diameter, PQ, is equal to the square root of x2 take x1 squared plus y2 take y1 squared, or we can use Pythagoras. So on your picture, draw a triangle and use Pythagoras and find the height and the distance. If we use our formula, we can now substitute in the values. So minus 10 minus 2 squared plus 11 minus 15 squared, which gives us the square root of minus 8 squared plus minus 4 squared which is the square root of 64 plus 16, which is the square root of 80. We can simplify this to give us 4 root 5 using our surd rules or our calculator. 4 root 5 is the length of the diameter, so the radius is half of our diameter, so half times 4 root 5, which is equal to 2 root 5. And now we can find the equation of our circle. So the equation of our circle is x minus a squared plus y minus b squared is equal to r squared. And if we substitute in the values we've got, we get x minus 6 squared plus y minus 13 squared is equal to 2 root 5 all squared, which we can simplify to give us x plus 6 squared plus y minus 13 squared is equal to 4 times 5, so 20. So now complete the following questions. So from exercise 6a, the questions shown, and from exercise 6c, questions 1, 2, 3 and 10. If you need any help with these, make sure you come and ask one of your teachers before your homework is due.